All right, so let's do dynamic analysis. We're going to use this program, key.7zip. I think I do need to download this one. So I'm going to copy the link and go into my malware analysis machine and open Firefox. And go there. This is PMA 221. Yeah. All right, and so it's a 7-zip file, so I'm gonna extract it with the 7-zip file extractor, which is already installed here. Right click. I said right click. Okay, and then Microsoft hides all the good stuff now behind show more options because they love to waste our time. And that 7-zip extract to, say, a folder called key, that would be fine. Okay, now I need a password, and the password is malware. This is standard. When you have malware, zip it and put a password on it so nobody runs it by accident, and typically use the password malware. So now there's a key folder, and in there's a program called key.exe. And that's our malware we're going to analyze, but before we run it, we're going to start a bunch of monitoring tools. And the first thing, by the way, before you do dynamic analysis, you start with simple static analysis to give you a clue what you're looking at. So let's look at PE view and see what we've got here. In PE view, I can open that file, which is on my downloads folder in here. There it is. All right. By the way, I should mention some of these tools actually execute the malware, and it's not obvious. So always work in a contained environment. I've had this happen. I think I'm just looking at it, but in fact that tool runs it without it being obvious. So I always want to be in a safe, isolated machine whenever you're working with malware. Even if you think you're doing a safe operation, you might not be as safe as you think you are.
Would it be a good practice to have manager?
You could do that. Yeah, we'll do essentially that when we run it. Yeah, but yeah, I mean, just you. Well, yeah, you could, yeah, but with practice you learn what your tools do. But I mean, there's some tools that look like they're not running it, but in fact they are. And I've been analyzing like PHP malware. There's a decryptor, and I tried running just a decryptor, but I made a mistake and ran some of the malicious commands after it. So it's dangerous, you know.
Windows system,
Yeah.
like if it's running, it doesn't have a PID, right?
Well, yes, unless it's a rootkit, and then you wouldn't see it. Rootkits hide things, yeah. But yeah, Task Manager will usually tell you if it's running. All right, anyway, so here's what it looks like, and let me just check what I wanted to point out here was the address table. Right, we're going to look and see what functions are here. If you look at the import address table, which is here, then you see it does something with the registry, opening and setting and closing, setting a key. Then it has a few functions called from kernel, and then a few things from user, and that's it. Again, just 3 libraries. All right, and so those are the libraries it uses. No immediate conclusions from that, except you see it's a very simple file. Then we can use bin text, like I say, something you should probably always do because it gives you so much information so easily. Bin text on that program, which is downloads, say key.exe, and go. All right, and so now the first thing we see is the usual stuff, this header, the headers, the section headers, the random junk that isn't real strings. And then, down here was some stuff. This is where you really doing something. This is clearly a keylogger. Only a keylogger needs to record things like this: shift, caps lock, up arrow, down arrow. That's why it's there, so it can record your key presses. So this gives you a pretty good clue that this is a keylogger. And here's a likely indicator of compromise. Here it is making a file that will look like something innocent, like a device driver or something, but this is created by the malware. So this is probably an indicator of compromise, this VMX32-64 program. And here, by the way, is the persistence mechanism. It's amazing what you can get from here. This is a Windows registry key that is, this is something to automatically run every time you boot up. So it's one of the things are called ASEPs, Auto Start Extensibility Points. There are about 30 of them that will automatically launch things on Windows, and that's how you get persistence. So even when you reboot, the stuff will automatically start. So it looks like it's using this one. So, by the way, you don't really know any of that. Those are just strings that were found. You haven't really proven that they're connected to logic in this fashion, but those are pretty strong indicators. And I think there's nothing else too exciting here, although since if there's networking, we might find an IP address or something in here, but I don't see any, and I'm not sure I don't think this program does any networking. So anyway, you can get quite a lot from BinText. And there we go. All right, and now we'll do dynamic analysis with these things: Process Explorer, Wireshark, and Process Monitor. So Process Explorer is here. Process Explorer is the superior task manager. It's written by Sysinternals. Mark Russinovich was a teenager in Russia, and he loved Windows NT, and he kept reporting bugs to Microsoft. And he would fix them, and he'd report more bugs and drive them nuts because he knew more about Windows than anybody, until they finally bought his company and started building all this stuff into Windows. And his Sysinternals tools are wonderful and totally let you analyze everything Windows is doing. And so Process Explorer is the super task manager. And so here it is, and what this does, this shows you all the processes on your machine in the order in which they launched and color-coded and grouped. So when you boot up your machine, it's going to create the registry, start the system, then it's going to start all the background services before you log in. And they're up here in this section. And one thing you'll see is a whole bunch of them are service host, like this. The same executable is used to load many services. So this particular instance of FCC host is running the DCOM server and the systems event broker and background tasks. And if you go down here, there are many, many more of them. These are all the background services. Remote procedure call. Each one of these is running one or several background services, of which there are about 100 running. And then all this stuff launches before you log in. So it's all running with a high privilege account like system, because you haven't logged in yet. Down here, here's WinLogon. This is where you logged in. It didn't even know who you are until this point. All the of that there is the background Windows tasks. This is you logging in. After you log in, it launches Explorer. Explorer is the main process that draws the desktop and all the windows, and everything you launch is a child of Explorer. So here's Firefox and other things down here. So, all right. That's what's going on here in Process Explorer. That will show you all the currently running processes. Now, Wireshark we know about. Just kicks up network traffic. Now, we used Wireshark before to study archived traffic, which, by the way, is the best use of Wireshark. Wireshark is not a very good tool for system monitoring live traffic for two reasons. In the first place, it just accumulates data in RAM until it uses up all the RAM and crashes, so you couldn't turn it on to continuously monitor. In the second case, it's not safe, because Wireshark can interpret thousands of protocols. Those are written by random amateurs contributing to protocol handlers, and some of them have flaws. So if you turn on Wireshark sniffing and let attackers attack you, they can take over your machine through Wireshark. So the correct way to use it is you capture with just a command line command, like TCP dump, and save the file and then analyze it later with Wireshark. It has all these graphical features to make it easy for an analyst. However, here I'm going to analyze it live because I'm not letting an attacker attack me. I'm trying to catch a small amount of network traffic from one piece of malware. Yeah? What's that? Process Explorer, you say? What about it? That border, you say. Let me see. What's your question? It is. The order is chronological. That's why you have the boot up stuff, then all the background stuff, then login, then Explorer, then everything you launch. Yes, it is chronological. And therefore, it's also color-coded. User land is blue, and these other colors are kernel land. Very good questions. Very important to know. Anyway, so here, so Wireshark, I'm just going to start it sniffing. I don't care about your update. And here's Wireshark. Okay, so I'm going to, this one, Ethernet, is the one that goes out. So I'll just start sniffing on that. And VMware is going to want a password, because technically it's picking up traffic going out to the world. All right, I don't think this malware is going to make any traffic anyway, but you run that to catch it. And the last one, a really important tool that is not as common, is Process Monitor, always confused with Process Explorer. Process Explorer lets you see the currently running processes. Process Monitor is really important for malware analysis. Process Monitor records all the events and makes a log. And really all it's doing is reading the Windows event logs and creating more useful information. The Windows event logs are on by default, but they're far too granular. If you just open a folder and create a text file, that's like 100 events. It'll drive you crazy to go into that thing. So there are tools like this that just take the normal Windows event log and simplify it so you can understand it. So this is Process Monitor, and I wonder what that's doing. No event. See if the capture is going to start. That's a new problem. I haven't seen that before. Unable to load the device driver. I may not be able to demonstrate this one live. This is strange. Process Monitor. I wonder if I log as administrator. There it is. It's already elevated to administrator. Oh, I need to run 64-bit. That's probably it. Let's try that. Oh, this is ARM. Yes, I remember. And I think there is a Procmon A version. Let me go to my C tools. Yes, I am running on ARM. You won't have this problem if you're running Intel, but if you're running ARM, because you're on Intel. Yep. If you're on ARM, you have to run a different version of Process Monitor, and I should have it here. Procmon 64A. There should be 64A, which I don't have. All right, I'm going to have to get it. That's a good thing to demonstrate anyway. Download. There it is, Process Monitor. And I think if I download this one, it's a zip file, and inside there is the new one for the ARM-based Windows. So I go here and unzip. Yep, there it is, Procmon 64A, just for ARM. It's new. All right, that's the one I have to use on this machine. There we go. And now I can have filters to exclude things, and you often need them. Yep, here it is. I'm getting thousands of events, 91,000, 100,000, 120,000 events in the event log, and this is all before I ran the malware. So I want to hide all this. Now there are two ways to clean this up. Let me stop sniffing. One with the professional way is this. You click on each one and exclude this one. So exclude Procmon 64A. Then exclude this thing. If you're really cool, this is what you do. It takes about 30 key presses. You exclude everything that's there and then run the malware. If you're a sleazy slob, you do like I'm going to do. I observe the malware is named key, and I'm just going to look for processes named key and nothing else. Now that's not professional because it might load a second process and I'd miss it, but it'll do for what we're doing today. If you want to be professional, you do 30 key presses to ignore everything in the background first. So I'm going to turn on my filters, and I'm going to say if the process name begins with key, then include. So I'll add that. And I think if I say OK, that gets rid of everything. Now, all the background stuff is not there. And now I think I'm ready to run the malware. Let me just check my process monitor. This is the excluding harmless processes one by one. That's the professional way to go. And now you run the malware as administrator. Okay, so let's do it. And I want to set this up so we can see Process Explorer live. Now, Process Monitor will remember, but Process Explorer just shows you the currently active processes. And this is going to be interesting to see if I can set it up to be properly visible while we do this. In fact, let me close Firefox to simplify this display. We don't need Firefox anymore. That's downloads. That's Firefox. And you see Firefox has about 20 processes there. There they are. They're going away. All right, here's my user land. It's much simpler now. All right, so now I'm going to run the malware as I just need one of these, and I need to go to my downloads folder and into the key subfolder. And now I want to make this smaller. There we go. All right, now you can see, watch over here, you're going to see some stuff that only is there for a few seconds. When you run this thing, okay, over here, it launches a thing called key, and then conhost under it. And I think next time we'll see something else happen. It terminates the process here. But anyway, now this keylogger is running. And let me go to my instructions here. You run it. All right. And so there's a flag defined there. And now we can view the running malware and process monitor, and we'll see what's been happening. There. Oh, that's disturbing. I should have seen. Oh, I wasn't sniffing. I forgot to start sniffing. That's rude. All right. This is a mistake students often make. And if that happens, you have to clean it up. This thing does some damage to your machine. See if I have, removing persistence. All right, I think for, yep, this is what you have to do. I'm going to restart it anyway, but let me stop this part. I'll just show you, all right, that's already stopped anyway. All right, I'll talk about what should have happened. If I remember to start it, there's what you'll find. I won't do it live in the interest of time, but what you'll see is all these events. The key prologer comes in, and what you'll see, there's categories of events. There's registry events, file events, and other categories. Here it is opening a key. It's opening a key. Here's it creating a file, and so on. This is what it'll record. It'll record several hundred of these events. If you go through here and just watch what it does, here it is creating that file, VMX32 to 64 that we said it would create. Here it is creating a registry key. This is going to be the run key. The run key that makes, that causes it to automatically launch, and you can see all that. So it's really very nice. And it's good to get used to hunting through there. And now we can test the keylogger. You can see it go. And that's going to be, if I open Notepad, for example, just so I have something to type into, and I say, hello at DEF CON. Now, if I go look at the folder the keylogger lives in, which is here, get hold of it. There's a thing called log.txt. And if you open that, that's the keylogger, hello at DEF CON, and all the control keys and everything. So it's running a keylogger and storing the keys locally, not making any network connections, by the way. There's nothing in Wireshark except background traffic. This is just some kind of background traffic to detect your network configuration. Nothing leaving very much. And this, I think, is me closing the browser or something. Browser page is refreshing. But there is no actual network traffic from this keylogger. It doesn't send the keylog anywhere. It just stores them locally. All right. Anyway, so there's some flags to find there. And you can find the persistence mechanism. And by the way, the first time it runs as key.exe. When you restart the machine, it will start as this VMX32 to 64. So it'll be more hidden. And you can now remove them and examine these. And all right, and here's another one that does make network traffic, and you can find the flag. So there's a few flags to find there, and that's dynamic analysis. Like I say, pretty easy and fun. You deliberately run the malware and watch what it does. A nice, simple way to find out what it does. Again, you don't have to read any assembly code or anything. That's why this is a popular and fast technique. So give that stuff a try. I'll